Welcome back to AWE TV. My name is Mark Pizer, and with us right now is Ryan Damm, CEO and co-founder of Visby. Thanks for joining us.
Thanks for having me.
Sure. Visby focuses on light field technology, right?
That's right.
And you have a talk here titled Intro to Light Fields. Kind of a beginner level talk because there's some kind of misunderstanding about light fields and what they mean and what they don't. Go into kind of your talk and why people should start talking about light fields and why they're important.
I mean, so there's a lot of misconceptions around light fields. People kind of think of them as the litro camera, the refocusing camera, and that is one property of certain kinds of light fields. But what's more interesting to virtual and augmented reality, I think, is what I call a holographic light field. So it's the idea that you have all this light in a space, and no matter where a user goes, you can sort of synthesize different views. And what that means for VR and AR is you can get positional tracking in VR, you can deliver a view in augmented reality that changes as you move around it, right?
Okay.
And that's critical. You get that with a game engine or something like that, but for live action content or really good cinematic content, you need to be able to kind of capture the light field and play it back.
Why is that critical? What's the critical point about that?
Well, the critical point is if you just do regular photography, traditional camera, what you get is a single image from a single perspective. And the problem with that is that if the user moves around, they need new perspectives, which you don't have from
that might require a light
camera.
change.
Yeah, because there's a few things that happen. One is parallax, right? You look around the object as you move, you need to see new parts of the object, the other side of your coffee cup. The other thing that you miss out on if you don't have a light field is you don't get the reflections correct, right? Little sparkles and glimmers change. And that sounds like a trivial thing, but it's really not. One of the areas that we really need to work on in imaging for VR and AR is actually people's faces. I think that one thing that our brains are really tuned to react to is how realistic a person looks. And you get that sort of uncanny valley if it's not quite right. And those little glimmers are actually that critical missing piece. Right? The reason things look a little flat and a little plastic with today's human captured VR and AR is exactly that. They're plastic. There's no reflections.
Right.
So,
and our brains are attuned to that because we've seen so many faces over years. It's in our DNA.
Yeah. And we notice that about everything else too. We'll notice it about tables and plastic and metal. It's just it really bothers us if we see people's faces that look wrong.
Okay.
So.
And why should people care? I mean, with VR and AR, it takes them out of that experience, right? But we want to keep them in. We want to keep their disbelief suspended, let's say, and take any notion of, okay, this is fake, I get it, right?
Yeah, I mean, it adds to the realism, which adds to the immersion for something like a VR. But also, if this is going to be the new medium, if it's going to sort of supplant a lot of the way we consume content right now, television and otherwise, it's got to be good. It's got to be the same quality. It's got to be photographically correct, right? If you want to play a video game or watch a cartoon, things can look a little less correct, a little photographically off. That's fine.
We forgive it because a certain animation may have a certain style, and we go with that.
Yeah, and that's part of the aesthetic. And I think some of the most effective VR content to date has really leveraged that. It kind of sort of works within the constraints of the medium. But I don't think we should accept those constraints as a hard constraint for the future. So.
And your background comes from filmmaking. Your partner is the scientist side, so you have the creative and the technology.
He's a little creative too, but
okay. Nice. We'll let him know. We hope he watches this.
That's right. Yeah, I give him a little plug there. That's for you, Chris.
And at what point did you realize that we needed to start thinking about light fields? So while you were filmmaking?
Light fields in VR, I sort of looked at VR in the VR space and was looking at 360 video and stereo 360 and trying to figure out how to do it. And I was really frustrated with the fact that you didn't get positional tracking. It was sort of unacceptable to me that game content would have this really immersive element that live action wouldn't have. And so I actually called up Chris because of that and said, look, I've got some ideas around light fields. Here's some research papers that other people have published. Can we do anything with this? Can we build something that's kind of light field-like? And Chris really took it to the next level. He said, here's the latest signal processing insights. Let's go build a light field camera. He sort of said, well, if you're going to build a light field camera, you kind of need a light field codec. You kind of need a player. You kind of need everything.
And
so the whole scope just got large.
Yeah.
And so we went from this kernel of an idea to kind of the whole concept.
Okay. And you mentioned positional tracking. How does this help with positional tracking? Are we talking
just
about?
Totally necessary. If you want to play back content in either VR or AR, and have the user be able to move and not have the world or imagery just like glued to their head, you need to have a light field to do it.
So from your source where you're viewing it, a VR headset or an HMD with AR, your codec will take into consideration changes in, let's say, the frames, but in reality it's changes in the shadows from different angles.
Yeah.
And your codec and the positional tracking technology will notice those and take those into consideration better?
Yeah, that's exactly right. So it takes the sort of positional and angular tracking from the headset, right, and it feeds that into the file. and it
Okay.
sort of synthesizes the correct view on the fly. You know, you get that with a game engine right now, right? It sort of says, okay, well, where's this person looking and where are they positioned in space?
Sure.
And then it figures out where the virtual camera should be to deliver the right view.
Okay.
And what we're doing is we're building technology that will allow you to do that with non-game content, non-interactive, cinematically beautiful, photographically correct animation, and also live action.
Okay. And let's say without the light field codec, and everything goes to crap, what happens? You're talking fly, it just flies off the image you're trying to track.
Yeah, so there's
against
kind
the
of
world?
two approaches right now for people who are trying to do non-interactive content, right? There is the use a game engine anyway, right? So
Sure.
you've got to somehow get your models into a game engine like Unity or Unreal, right? And run it as a game engine even though it's not a game.
Sure.
What you get out of that is you get positional tracking, right? You know where the person is and you can update your view based on that.
Yeah.
The downside is you're actually running a full game engine, so you're not able to convey photographically correct views. You're limited by the client's GPU and you're limited by the game engine itself, which they can be very beautiful, but they're not really photoreal, right?
Right.
I mean, that's sort of, they're very limited in that regard. And you're still working in sort of a game engine environment. So that's one approach. That's decent, but it's still photographically limited. The other approach is photographically correct, which is to use, you know, array cameras or something and try to, you know, for VR anyway.
Right.
You have your array camera and you do the 360 stereo, and it can
Okay.
look really good and you stitch it all together. And that's photographically correct because it derives from real photography.
Right.
But you get zero positional tracking, right? The world's kind of glued to your head.
Right.
And there's a
Okay.
couple of like hybrid approaches, but in general, that's the sort of limitation. Either you have positional tracking and it's kind of cartoony, or you have no positional tracking and it can be photographically correct. And so, you know, light field's really the way to bridge those two.
Okay.
Let's get really photographically correct content out there, whether it's animated or real life, real world. And then let's get positional tracking too, because that's what these headsets demand. That's what makes them better than a 2D screen.
Oh, sure, right. And it keeps us more immersed.
Yeah, exactly.
Cool. And then, I mean, where do you think this is headed? You're giving this intro. And maybe next year you'll give an intermediate or an advanced
so, yeah.
discussion on
Yeah,
light
I mean,
fields.
we're sort of early days on light fields. Some people have sort of recognized this is the future. In practice, there's a lot of work to be done on educating people. So I think next year, hopefully, maybe some of the misconceptions will be bled out. Some people who are working in the space will have already kind of made enough of a splash that the general, at least the industry, will understand the terms a little better. And hopefully by then I'll be able to say, you know, hey, here's our product. Here's how to go integrate our code into your project. Here's how to use our codec. You know.
Yeah. How would that happen? Integrating it? Is it
Well, right now we don't actually have anything that's customer facing yet. We're in sort of like fundraising mode right now. In like 6 months or so, there's several ways it would happen. One, honestly, is for large players. We'll work with them on integrating our SDK into whatever their project is.
Okay, including a game engine, perhaps.
Yeah,
or-
eventually we will have game engine support for sure. It's on our roadmap. The shortest term thing we're going to do actually is a plugin for 3D animation software.
Okay.
So we will have a Maya plugin in the near term. I don't want to commit to dates or anything, but fairly soon we'll have a Maya plugin so an animator, even one who's not trained in VR, can go generate a scene, spend as much time as they want rendering the actual scene. So it's
Sure.
not limited by the client, right? If they want to make it photoreal, they can. And then the plugin will bake it down into a light field file, and then our light field player will be able to play it back. We'll work on kind of bundling the two so you can just create an experience and it goes right in the App Store.
Okay.
So the end consumer doesn't have to go find a light field player and
Right.
whatever.
Yeah.
But the idea is it will be a stream that is non-interactive, as photoreal as you're willing to render, and should play back in a very lightweight way on the client device.
Okay.
So that's the first thing we're going to build.
Okay.
We then have other sort of solutions for live action stuff. In the next year or so, we should sort of be able to lift the whole chain.
Okay, cool. Well, I hope to see next year that chain lifted and some of the roadmap unveil itself.
Thanks. We'll work on
Great.
it.
Thanks for joining
Cheers,
us.
Mark. My pleasure.
Thanks for joining us here at AWE TV. My name is Mark Peiser, and with us was Ryan Damm with Visby.